get the first slide. Hello, I'm Hugo Philion, co-founder and CEO of a blockchain called Flare. And today, I'd like to talk to you a little bit about data in blockchain and why it's not as good as it should be. So we term Flare as a third-generation blockchain. What does this mean? Well, in the beginning, there was Bitcoin and other non-smart contract platforms. And they allow users to perform very simple transactions, such as payments and escrows. Importantly, and the reason why we're all here, is they allow that to happen without a middleman and without censorship. Then came Ethereum and the plethora of other smart contract platforms. They add logic to these transactions in the form of virtual machines, letting people do slightly more complex transactions. And now comes Flare, the only third-generation blockchain, letting people build logic using a virtual machine, but integrating data natively to the chain. So why does the evolution of blockchain from first to third generation necessitate data? And we'll come on to that now. In a second generation blockchain, like Ethereum or Solana or any of those, there's not actually that much you can do with the logic that it offers. You can do payment transactions and escrows. But really the most credible product, the thing that has been built solely using the logic of those chains, is really Uniswap-style AMMs. So a smart contract blockchain with no data really can't be used for that much, and that's why we've seen oracles come around. Data is needed for the rest of the DeFi ecosystem that exists today, and it's needed for everything we want to do in the future. It's needed for real-world assets, bridging, interoperability. It's definitely needed for AI. It's needed for gaming, prediction markets, etc. You get the picture. Data powers almost all of the current and definitely all of the future use cases in blockchain. So a blockchain can do that natively, can give full security and decentralization to most everything anyone wants to build. So a little bit about today's oracles. You might say that we already have data, but not quite in the way you may think, and not true to the principles of how blockchain was founded. Data powers almost all current and future use cases, but we pay almost no attention to its safety, decentralization, and usability. Let me give you an illustrative example of how today's oracles work. You have a chain where people have built dApps, but that chain doesn't provide data, so they need to get it from somewhere. Someone builds a system external to the chain. Let's call them, for argument's sake, BlockLink. They and their friends set up some computers that aren't part of the chain, nodes. Let's say there are 9 of these computers in total. And dApp1 needs the USD Korean won price. And dApp2 needs the Ethereum USD price. Well, out of those 9 nodes, 3 of those nodes might decide to provide a price feed for USD Korean won, and 4 might provide the price feed for USD ETH. Well, firstly, 9 off-chain entities is not many, and this is an example. But in reality, it's only 31, which is still very few. Secondly, what is securing these off-chain entities? In reality, that isn't clear. There's no well-defined economic security for almost all of the oracles out there. Who are these entities? Well, for many price feeds, that's also not clear. And lastly, if you're a developer, you're faced with the uncomfortable situation where a popular price feed may have many contributors, but the price feed you need may have very few. In today's oracles, across the 2 most popular oracles, Chainlink and Pyth, the worst supported oracle has only 5 data providers. And this unnecessarily complicates the development experience, limits experimentation, and massively reduces the probability that we will uncover future use cases that are valuable to us as an industry. So to summarize data before Flare, oracles are applications that are external to the chain, like Chainlink or Pyth. They have minimal security guarantees. They're often not very transparent. Try to figure out what is securing your Chainlink nodes. That is quite a challenge. There's really almost no information publicly available about that. So they aren't really decentralized. Today's oracles have limited data, are expensive to use, and because each feed has a variable level of security, they create a complex developer experience. This leaves today's DeFi using poor data services with a trust-based security model. This is just like TradFi. But unlike TradFi, where there's regulation to ensure that your DeFi funds are safe against bad oracle signals, there's nothing in our industry that regulates that. And so today's oracles are securing around $40 billion worth of value with very limited security. After governments, today's oracles are by far the biggest risk to our industry. So we've covered perhaps the stormy clouds before Flare. Now let's move on to something a bit more sunny. Flare has two core data protocols that are built into the network. We call building this into the network enshrining. For pricing, we have the Flare time series oracle. It can deliver up to 1,000 types of price feed, and it updates every single block, which is roughly about 1.8 seconds. Every one of Flare's minimum of 100 validators contributes to each price feed. So this means that there's no more complex developer experience trying to figure out the risk of each feed. For data from other blockchains and from the web, we have the Flare data connector. This proves events from connected blockchains, like whether a user deposited an amount of tokens in a bridging smart contract so that those tokens can be used on Flare or on another connected chain. It also proves events from Web2 APIs, like the number of states won by a US presidential candidate, going to that, that example goes nicely with prediction markets. And these protocols are operated directly by the network validators. That is, they are enshrined into the network, and they are secured by the stake of the network. Taken together, these two protocols can facilitate the vast majority of data-driven current and future use cases. So I previously showed the structure of today's oracles in a little example. Now let's show the structure of Flares. On Flare, all validators contribute to all data. Currently, around 67% of FLR, Flare's native token, is either staked or delegated to the validators. All data in each oracle has the same security guarantees, and that is really nice for developer experience. And I hope you agree that this is a much more convincing and secure model than that provided by today's oracles. So to sum up Flare, Flare is the only layer 1 with enshrined oracles. It operates the EVM for smart contracts. This is the most adopted virtual machine in blockchain. This means that developers can easily build dApps on Flare with their data coming directly from Flare and secured by the network. The chain is optimized for data. Our oracles are fast. Data is cheaper on Flare, and using data is more developer-friendly because you don't have to choose, don't have to assess the risk of each feed. But I hear the question, what about restaking? What about eigenlayer? Well, enshrining data services is greatly preferable to building them with restaking, and let's discuss a little bit why. So some people have proposed securing oracles through restaking. How does restaking work? In brief, it allows people to stake Ethereum to validators on Ethereum using a liquid staking protocol. By this mechanism, the staker receives back from the staking protocol a derivative token that represents a claim on the staking position. Financially, that position looks like ETH plus earnings from the validator minus any slashing events. And slashing events is what is key here. The staker then takes that derivative token, the liquid staked ETH, and stakes it against an actively validated service. This might be an oracle, it might be a bridge, it might be some other form of service. Within this model, the staked liquid staking token can then again be staked to a second AVS, and then using the same mechanism, a third, and so on and so on. So that's an introduction. Slide's a bit buggered. So that's an introduction to restaking and what's happening with AVSs. So what's happening here in the economic sense? Well, the initial liquid staked ETH is a portfolio position that represents ETH, earnings from the validator, and slashing risk that comes from validation. This asset is then used to secure an AVS service. This mechanism of restaking transfers the risk of slashing in one service, in this case validation, directly to an unrelated service, the AVS. And hence, at any time, the value of the asset securing the AVS can reduce, i.e., it can depeg from the assumed value. Under the eventuality of a depeg, this potentially can lead to unpredictable behavior in the AVS due to over-leveraging. For example, the economic security of a service no longer matches or exceeds the downstream value relying on that service. An oracle securing 10 billion of value may suddenly have far less than 10 billion securing it. So services operated by AVSs essentially have an inferior type of asset securing them relative to Enshrining, which uses a layer 1 asset. So then, what is the second layer of restaking? I've already restaked in one restaking protocol. Now I've got my token back through a liquid restaking protocol, and I want to restake again. So what happens at the next stage? Here, the problem from the last slide is compounded. It's quite simple. As we get further along in the rehypothecation of the asset, i.e. the liquid restaked token from AVS1 is now used to secure AVS2. But AVS1 also has slashing risk. So AVS2 is transferred both the slashing risk from Ethereum, but also the slashing risk of AVS1. Thus, the asset securing AVS2 is now an inferior type of asset, both to the asset securing AVS1 and to the asset securing Ethereum, or in contrapoint, an enshrined L1 service. So to come on to enshrinement, it's really very simple. Why is this a better and clearer economic model? Compare this to the enshrined services on Flare, compare the AVSs to the enshrined services on Flare, consisting of, at this moment, validators and the 2 data oracles. All Flare is available as stake to those services, either directly or through a liquid staking protocol. If slashing is enabled, there is no slashing risk to the services as a whole, only directly to the validators on Flare. There is no risk to the enshrined services that some upstream service can affect their operation by impairing their stake capital, because the enshrined services on Flare enjoy the full security of using the unrehypothecated L1 token for safety. As these enshrined services provide utility and the adoption grows, so the value of the stake securing them should grow with it. This is unlike in an AVS, where the securing value is not related to the protocol, it's related to Ethereum. Importantly, And importantly, practically every type of service that can be secured by an AVS can instead be enshrined. So now back to Flare. We've covered how Flare is an L1 EVM chain with enshrined data protocols, oracles. And now we come on to the next thing that we're building to improve both the developer and user experience. You can build dApps on Flare that use data from the enshrined oracles and harness trusted execution environments for complex and data-heavy compute needs. To us, this is very exciting, but why? So what's the problem? What's the problem we're dealing with? Everyone is used to very high-quality applications on Web 2, like Instagram, X, or Apple Music. These applications require huge amounts of data and are very compute-rich. But blockchains aren't capable of handling this amount of data or this amount of compute. For instance, to store just 1 gigabyte of data on Ethereum would cost you $60 million. And on Solana, it would cost you $10 million. By contrast, to secure this in a TEE using Google Cloud, it costs 27 cents. So this means that dApps built on blockchains are incredibly basic, and they don't meet the expectations of the vast majority of potential users. Ultimately, this limits what can be built and is a massive barrier to adoption. Just 2 examples complete the picture here. With a centralized exchange, like Binance or any of the other exchanges, there are fee tiers for how much you trade. This is impossible to compute on-chain. It is impossible to keep a track and compute a particular user's trading on Uniswap and to do that on-chain. And this is why Uniswap doesn't have fee tiers like its competition in the CEX world. Another example, OpenSea, with its NFTs, only acquires 5 data points from the blockchain. This is not the kind of user experience that the vast majority of people in the world are looking for. It's only us in this room that tolerate it. So TEEs, trusted execution environments, can solve a problem, but what are they? A TEE is a secure enclave within a CPU. You use one every day in your Apple iPhone for Face ID. They enable trustless, tamper-proof, and confidential computation. This is referred to as verifiable compute, i.e., knowing the inputs, the output given can be verified for correctness. This is an incredibly useful quality for blockchain dApps. So how does integrating TEEs give users feature-rich dApps whilst not reverting to Web 2 trust assumptions? Well, in Web 2, a user relies on the application provider for the program integrity. You can think of program integrity as being the rules of the application. For instance, on X or Facebook, that when you log in, your account will still exist. You trust that the provider will not give all of your private information to anyone that asks it. This is program integrity. You also trust that application and that application's owners for compute integrity. You can think of that as being the expected outcome of using the application, i.e., that when you do something, you get the same expected result every time. For instance, that when you send someone $100 from your bank account, $1,000 is not sent. In Web 2, for both of these cases, program and compute integrity, you, the user, have no control over either. You can be banned from using Instagram or X without any recourse. This is program integrity. Your search results on Google may deviate markedly from day to day for the same query. This is compute integrity. But by combining Flare and verifiable off-chain compute, we can build dApps where the program integrity, that is the rules of the application, are embedded in the blockchain. And the compute, whilst taken off-chain into a trusted execution environment, is verifiably correct according to the rules of the app embedded on the chain. So this means that an X, an Instagram, a shopping application, or anything else can be built where you have certainty over the continued existence of your account and how the data you're passing to that application is processed. You can build or use Web2 applications, but with blockchain guarantees. And this is why we're very excited about TEEs. But of course, these applications need data. And in order to ensure the integrity of that application, then the data sourced must be sourced in a decentralized way. And the only real solution to that today is Flare. So I've made a big pitch as to how we can get to adoption, data, and compute. But let's take a step back and ask, what are the next steps that we're working on? Well, Flare is a layer 1 EVM-based blockchain that enshrines data services to provide developers a safe and easy substrate for building dApps. We're bringing in verifiable off-chain compute through TEEs so that developers can build experiences for users that are better than those available in Web 2. Better because they merge the rich experience of Web 2 with blockchain guarantees. What are our immediate next steps? First, we've developed the data services on Flare. Our next major project is to get those data services available across as many chains that need it, safely, so that everyone across the space can harness Flare's enshrined data model and have more security over how those dApps are operating. Our partners at Flare Labs are using Flare's enshrined data services to launch a bridge that couldn't exist without these services for the highest value non-smart contract tokens in the space, Bitcoin and XRP. The bridge is trustless and works through over-collateralization. This unlocks the value of Bitcoin and XRP on Flare and potentially through our bridge partners into other ecosystems. And excitingly, in November, we're launching our first hackathon with Google Cloud around verifiable off-chain compute using trusted execution environments. We're looking forward to seeing the first versions of feature-rich, user-friendly applications being launched on Flare. So just a little bit about Flare's ecosystem. It's growing fast, backed by a dedicated set of currently around 150 partners across various sectors, from DeFi to infrastructure to wallets. We've been joined by some of the world's leading infrastructure providers, including Google Cloud, Figment, Anchor, they're all competing within Flare's independent validator set. They don't get special privileges. But these entities boost the network credibility, its stability, and maintain service around the world. Security is a top priority for our ecosystem. We collaborate with Immunified to safeguard our applications and end users. We've implemented proactive risk management with Hypernative and collaborated with Elliptic for chain analytics to retain compliance. In turn, these integrations support our institution-grade custodians, Fireblocks, and HexTrust. Our recent integration with Layer 0 v2, along with partnerships with Stargate and Polyhedra, brings bridging to Flare and potentially the opportunity to bring our data to the other networks. And they bring USDT, USDC, and Ethereum to the network. So on Flare, DeFi is currently growing very fast. A community-approved emissions program to incentivize people to build in Flare and to bring their value to Flare's DeFi is distributing over 500 million Flare tokens to users of our trading platform, lending protocols, and staking solutions. With the upcoming F-Assets bridges, that is, the bridges for XRP and Bitcoin, Flare is poised to have an exciting 2024. We've just reached 1 million addresses, and our on-chain transactions and ecosystem TVL are climbing fast. So to sum up, Flare is the first third-generation blockchain. It does what Bitcoin did with transactions, what Ethereum did with adding logic to those transactions, and it adds data into the mix through enshrining the data protocols on the chain. It steps beyond just being able to build applications and allows developers to build applications with data sourced directly and securely from the chain. It brings the ability for developers to build data and compute-rich applications that users will love. Flare is connected to 75 chains and 50,000 dApps through its partnership with Stargate and Layer 0 v2. Its on-chain ecosystem and TVL is growing rapidly. It is secured with institutional partners such as Google Cloud, Figment, A41 in Korea, and others. I hope you can come and use Flare, and thank you for your time.